With the skeleton in place, you are almost ready to start the skinning process. Before moving on, here's a tidbit of insight on general workflow. You may be wondering if the skinning process ought to take place at this time or only after the whole rigging process is completed. The answer to that question varies between rigging artists. Some artists prefer to do the skinning first. Others prefer to do the skinning after the rigging process is completed. Ultimately, it doesn't really matter much as long as the end result is the same. This movie chooses the approach where the skinning process is completed before any rigging is attempted. The argument made here is that if you discover a problem with joint deformation as you are skinning the model, it is easier to adjust the skeleton if it hasn't been rigged yet with IK solvers, constraints, wiring expressions, and reactions. Either way, it helps if the skeleton is animated. This way, it makes it easier to study skin deformations as far as the joints are concerned. Hide the mesh layer. In this approach, and because the skeleton has not been rigged yet, all you need is simple forward kinematics rotations on the various bones. In essence, you need to establish full range of motion for the individual bones. Not all are meant to rotate the same way or by the same amount. For example, an ankle has more freedom of movement than a knee, which only rotates in one direction. Also, before you start animating, it is a good idea to freeze the transforms on the skeleton. Freezing transforms would introduce list controllers and zero out the position and rotation of selected objects. This has been discussed in other movies and tutorials on this channel. Freezing transforms creates position and rotation lists for the selected object. There are many benefits to freezing transforms. One major benefit is that you can go back to the frozen position and use it as an original pose. Freezing transforms, and particularly rotations, can also be beneficial for reducing rotation problems such as gimbal locks. Another benefit happens when you're using wiring and expressions. The fact that you are using list controllers helps with layering animation and when relying on expressions and reactions. To make a long story short, always freeze transforms when dealing with a character rig. At this time, notice that any skeleton bone is using default position XYZ and Euler XYZ rotation controllers. To freeze transforms, you need to select all bones in the scene, Alt-right-click and choose Freeze Transforms from the quad menu. A dialog appears with a warning and a bit of explanation on what we just discussed. Click Yes to proceed. Select any bone on the skeleton and notice the added position and rotation list controllers. The first frozen controller in each list ensures you can go back to the current pose at any given time. The second zero controller is the one you would want to animate. When you need further controllers for additional animation, such as wiring, expressions, or reactions, you can add to the list through the available option. At this point, even if you go crazy posing your skeleton, there's always an easy way back. All you need is to select your skeleton again, Alt-right-click and choose Transform to 0. This would take you back to the original stance which you froze earlier. Before you move on, set the animation length to about 400 frames. In fact, you'll need to extend that even further a little bit later. To animate the skeleton, it is not a difficult process, but it is time-consuming. You basically need to rotate every bone through its full range of motion. What you need to do is animate rotation extremes every 20 frames or so. For example, select the left toe bone and enable auto key mode. Go to frame 20 and animate the bone to rotate up on its local z-axis for about 50 or 55 degrees. If you want, you can use angle snap, A on the keyboard. At frame 40, 20 frames later, you want the toe to come back down to rest in its original pose. Simply copy keyframe 0 to frame 40 by shift dragging it. At frame 60, rotate it down, again by about 50 degrees. It's unlikely that you'd need such a sharp angle, but you're going for extremes here, so it's fine. Again, copy the rest pose from 0 or from 40 to 80. As far as the toe is concerned, that's the only movement you need. The foot is a different story. Select the left foot. Make sure you are at frame 80. Right-click the slider bar and force a rotation key. This forces a rotation key at frame 80 so that the foot doesn't rotate prior to that. At frame 100, rotate the foot up by about 60 degrees. At frame 120, you need a copy of keyframe 80 to bring back the foot to its original pose. At frame 140, rotate it the opposite way by about 45 degrees. Bring it back to rest at frame 160. Contrary to the toe bone, the foot, or ankle bone, has a bigger range of motion. This could include a twist between frames 160 and 240 on the world Z-axis, or even a tilt rotation between frames 240 and 320 on the world Y-axis. The knee is easier, as it only needs to rotate in one direction on its local Z-axis. Make sure you force a rotation key for it at frame 320 by right-clicking the slider bar as you did earlier. Rotate it for about 120 degrees at frame 340 and bring it back to rest at frame 360. As you can see, the process is not hard, but it is time-consuming as you move up the chain. If you don't want to go through all the skeleton bones, an animation file has been provided to you. You'll definitely need to do this kind of manual work for your own projects, though. Exit Auto Key Mode and then extend the animation to 2600 frames. Select the whole skeleton. Go to frame 0. Delete any keyframes you have already created. You are about to merge in an animation file that will take care of all the bones in the scene. Again, make sure all bones are selected, and then choose Animation, Load Animation. Browse to the folder where you have downloaded the files for this tutorial. Select the file named Skeleton XAF and click on Load Motion. I will add a side note at this point that the load animation function works flawlessly here for a reason. The animation file was created with a skeleton identical to the one you are working on. This means that the bones not only have identical names, but also identical animation list controllers for the position and rotation tracks. If that had not been the case, then you would need to spend some time remapping all that information so that the incoming animation keys find the proper hosts in the current scene. In this case, the skeletons are identical in every way between the incoming animated skeleton and the one you are currently working on. You may notice a couple of things that will attract your attention. First, there seems to be more animation detail on the left side of the skeleton. The toe, ankle, and knee bone, as well as the arm, hand, and fingers, are animated only on the left-hand side of the character. Arguably, you could have animated both sides, but once you have skinned one side properly, you can use skin mirror tools to ensure the opposite side deforms correctly. In that sense, you don't really need to spend time animating the right side. Also, notice between frames 880 and 1040 that the current animation is not taking into account the FK and IK bone branches. That's because these branches will be used for animation purposes only, not for skinning. The mesh will only deform based on the original skeleton bones and the roll bones, which ultimately will be driven by the FK-IK branches. Also keep in mind that the animation introduced is here only to serve one purpose, and that is to help with the skinning of the character. Once that is done, you would need to wipe out the animation before you proceed with the rigging. Bring back the mesh layer into view. In the next movie, you apply the skin modifier to the mesh.